I have.
The presentation has not been uploaded. Let me just upload it. But in the meantime, Sydney, please continue with how you found the 1.78.
The 0.16 plus.
How did you get 0.16?
I did 5 minus 5.4, then square root of the difference.
Okay.
Then I found 0.16. One again, I went to 3 minus 5.4. So the difference, I squared it, which gave me 5.75.
Okay, just a moment. So we're saying 3 minus 5.4. You square that. 5 point what?
So I know.
5 point what? Oh, who is not with us?
I don't know what is going on because around 16 I logged in. I couldn't see anything.
Okay, so we have numbers 5. Okay, so that slide, those slides are the ones we're using. Just make it a full screen. Make those slides a full screen. You'll be able to see. So we are on number 4, which says find the standard deviation in 1, 2, and 3. So in 1, we're given the numbers 5, 3, 8, 5, and 6, right? So we need to find the standard deviation. So when you look at those numbers, are they grouped or ungrouped?
Yeah, I'm grouped.
They're ungrouped. So what is the formula for finding standard deviation for ungrouped data?
It's not this square root of what?
So you need to revise the past lectures. Otherwise, you'll be left behind. Okay. So the formula is square root. The formula is square root, and under the square root we have a fraction. Then the denominator is summation of x minus x bar squared. Okay, over n minus 1. Yeah, over n minus 1. So that is the one that we are doing now, and that's what Sydney was explaining. So under the root, we had 5 minus 5.4 because the mean of those numbers is 5.4. So 5 minus 5.4, you square that, plus 3 minus 5.4, you square that, plus 8 minus 5.4, you square that, plus 5 minus 5.4, square that, and lastly, plus 6 minus 5.4, and you square. Okay, then the sum, then you divide by n. What is our n in this case?
That's number what? It's 2 or number 1?
Yes, we're still on the formula for standard deviation. Our n is the number of observations. So the number of observations here are 5.
Not 5.
5 minus 1 will give us a 4. So back to Sydney, check your calculator because mine says that 3 minus 5.4 and you square that should give you 5.76 and not 5.75.
Oh yeah, I guess so. Yeah.
That okay? So just these few mistakes can affect your answer because if in my solutions the final answer is 1.8, Okay, and you give me 1.78, or I say the answer is 1.81. Okay, then you missed some numbers and you gave me 1.78, but everything that you have done is correct. If the total marks were 5, I'll give you a 4 out of 5 because you've not given me the correct answer. Okay, so you need to be checking your calculators and make sure you write the numbers that you see on your calculators. Otherwise, you might lose marks for not just copying the correct number from your calculator. Are we together? So we should find that this standard deviation, it's 1.81 for the first one. So, let me just respond something on WhatsApp. Okay, so are we together on that? So we can similarly find the standard deviation for the data set in 2 and 3. Now we are going to proceed to grouped data. So just the slides are a bit faint. Just make your slides on full screen, then it will be clear. Okay, so are we together? So we're now going to move into grouped data. So with grouped data, what defines the grouped data? You have classes, okay? So you have classes like 10 to 15, 15 to 20, 20 to 25, okay? So how do you call those, like 10 to 15 are the classes. How do you call 10, 15, 20, and 25? Like these numbers that are at the beginning of the classes. How do we call them?
Lower limits.
Lower limits, right? And the other side, 15, 20, 25, 30. Upper what? Upper limits. Okay. So what about boundaries? What's the difference between upper limits and upper boundaries? Or lower limits and lower boundaries? The difference? I'm waiting. I explained this when we were talking about how to construct a frequency distribution table.
I think there is
lower limit and lower boundaries.
I think there is no difference because the difference between that is 0.
No, you're still. Yeah, no, I'm not satisfied with that answer. Please add more flesh.
I don't know a better way to use, but let's say if we had, let's say, the difference between the upper limit and the lower limit in diagonal.
Mm-hmm.
If it was 0.5, we add 0.5 to the upper limit to get probably 15.5, and we subtract from the lower limit to get.
So when you do that, what are you obtaining when you're adding those 0.5 and
minus? You're trying to close up.
And when you close up, what do you get? Do you get upper limits or upper boundaries?
You get upper boundaries. You get upper boundaries.
Yeah. Okay, so yeah. So whenever there's no difference between the upper limit and the next lower limit, Then what defines the classes are upper boundaries and lower boundaries. Is that clear? Now, when there are spaces from the upper limit to the next lower limit, if there's a space, then it means that those are they are just limits, they are not boundaries. So that is why there's a need now to close them if you want to obtain boundaries. But in this case, we are saying that the lower limit is actually the same as the lower boundary because there are no spaces. You can either call them boundaries or upper limits because they're just the same. That is why I wasn't satisfied with that, the first answer, because it is only in the case when there is no space between the upper limit and the next lower limit, when the lower limit is the same as the lower boundary. Okay, are we together?
Yes.
Okay. So now that we have lower limits that are the same as lower boundaries and upper limits are the same as upper boundaries, we can use those terms interchangeably. Okay, so we can use those terms interchangeably. Now, in this case, are we together? It's quiet?
Yes.
Okay.
Yeah, listening.
Okay, so we're looking at grouped data. Now, we have values from 10 to 15, and observations that fall within that class are 3, right? Then
Yes.
from 15 to 20, we have 9.
9.
From 20 to 25, we have 5.
Right.
And from 25 to 30, we have 13.
13.
Now, there's one thing that we have to remember. Please, let me just respond to a message on WhatsApp. Okay, so there's a term that we'll be using frequently in grouped data, and that is the midpoint of the class interval. So the midpoint is just obtained by adding the lower boundary plus upper boundary divided by 2. Or we can say lower limit plus upper limit divided by 2. So that is the midpoint. So what is the midpoint of the first class? What is the midpoint of the first class?
12.5.
12.5, okay. And the next class?
17.5.
17.5, right? Okay, so that's how we get the midpoint. So to find the mean, now we want the mean. Remember, in grouped data, we were adding all observation and you divide by the number of the observations, right? Now in grouped data, we first sum xi times the frequency. So that is where the xi's are the midpoint. So you get the midpoint for every class. Okay, then you multiply it with its frequency. After that, that sum you divide it by the sum of the frequencies. This is the sum here. Okay, so we'll see from an example how to do that. Or maybe we should just go straight into it. Okay, so let's check in on slide 2. We are asked to find the mean for this data. So we are told, we are given some classes. We're talking about the mean, so let's go in, let's have an example. which is on slide 2. The class is from 0 to 10.
10.
The frequency is 45.
45.
10 to 20, frequency is 75. 20 to 30, the frequency is 60.
60.
30 to 40, the frequency is 40. So what does our formula say? The mean, which is x bar, is just summation of xi, fi over summation of f. Okay. So go to slide 3. We first now make
Point.
a column for the midpoints. Okay. So we get 0 plus 10 divided by
2.
2. We get that 5. 10 plus 20 divided by 2, we get that 15. Then these are the midpoints for the other classes. So are we clear on the midpoints?
Yes.
Okay, now the formula says xi times fi, meaning every midpoint you multiply by its frequency. So this is the next column there. 5 times 45, you get that 225. 15 times 75, you get that 1,125. 60 times 25, you get that 1,500. 40 times 35, we get 1,400. Remember, there's a sum here. That means you get the total. So we're going to get the total of that and put it there. And we're going to divide by the sum of the frequencies. So we have to add the sum of the frequencies. We have to find the sum of the frequencies as well, which is 220. Divide by 220, and we have that 19.318. Any questions on the mean?
Nice, clear.
Okay, so the next thing that we want to do is to find, to see how to find the mode. Remember, what is the mode of a data set? What is the mode?
It's the most common observation or score.
Yeah, so it's the most common observation. Now, if to find the mode, like in this first example that we had, 3, 4, 3, 9, 5, 13. Which one would you say is the mode? Are you able to identify the mode from there?
Yes.
Pardon?
Yes.
It's 5.
I need answers. Are we able to identify the mode?
The mode is 5.
25 to 30.
The mode is what?
5.
25.
Is 5. How did we get that 5?
No.
You're saying the mode is what?
I think it's 25 to 30. The most frequency.
Oh, 25 to 30. Why?
Because the frequency is how many times? 13. Because of 13, the number of.
Because there's the frequency is highest in that class interval.
Yes.
Okay, but do you know that when we say that we have, what is the frequency in that 25 to 30? What is the frequency?
It's 13.
13.
Yes.
Now, what that means is just that the values that are between 25 and 30 are 13. Now, you don't know whether those values, that is a 25, you don't know which one will be the most frequent. Whether it's 25 or a 26 or a 27 or a 30, You see what I mean?
Yes.
Or 29, there we just know that there are a lot of values in that in that class interval, and we are actually right to say that one of them could be what? The mod. But we don't know because it is a class interval. You see my point?
Yes.
Yeah.
It is a class interval from 25 0 to 2. Okay, let me just yeah. So it's a class interval from 25 to 13. I mean to 30. But we don't know which value is the most common value in that interval. What if it's a 25? What if it's 20? If we had maybe 6 27s, okay? So we don't know. So because it's grouped data, we need to use the formula, okay? So our formula just says that to find the mode, we have to get the lower limit. We add it to, in this bracket, we have the frequency of the model class. So the first thing first in finding the mode is to identify the model class. The model class is just the class that has the highest frequency. Okay, you had a point when you said the class that that contains the mode is the one from 25 to 30, but we want to know the exact number, which is the exact number that is our mode. Okay, we can't just say it's 25 to 30. We need an exact number. So to find an exact number, we use that formula. So in that formula, we first identify the model class. The model class is the class with the highest interval. Is that clear?
Yes.
So after we identify the class with the model, with the highest frequency, we now use the formula. Now this formula just says that you get the lower limit of the model class. Okay? Then you open your brackets and the numerator has the frequency of the model class minus, now this fm minus 1 is the frequency before the model class. Okay, and down there we're going to divide by the frequency of the model class minus the frequency before the model class. This is still a fm minus 1. Okay, then plus frequency of the model class, which is fm minus fm plus 1. This means that the frequency of the class after the model class. Are we together? Then we have to multiply by the class width. So the class width is obtained by subtracting any two lower limits, okay, or any two consecutive upper limits, any two consecutive lower limits, or any two consecutive upper limits. Like 15 minus 10. What does that give us? 5. So that is our class width. You can also obtain it from subtracting any two consecutive upper limits, like 20 minus 15. So that is our class width. Or we can say 20 minus, or 25 minus 20. We still get the same number. Okay. So that is how we obtain the class width. So we have the width, frequency of the model class, frequency before the model class, frequency of the model class, frequency before, frequency of the model class, and frequency after. And this is the lower limit. So in that case, what will our L be if we wanted the mode?
25.
Okay, we first identify the class with the highest frequency, which is 25 to 30, right?
Yes.
Now, the lower limit will be 25, right? The frequency of the model class, what is it?
13.
13, okay. Frequency before the model class?
5.
Yes. And frequency after the model class, what is it going to be?
There isn't here. Is it not 0, madam?
So when there's no frequency after, then you put a 0. Okay. So if the model class was the first one, 10 to 15, and what was going to be the frequency before the model
3.
class? Frequency before, if the
If
model
it
class
was the
was
model,
10 to 15,
0.
0. Okay. So
Yes.
if the frequency before was going to be 0. Okay. So let's go back to our example and see how to find the mod. Okay, so we are back to that example where we have 0 to 10, 10 to 20, 20 to that, 30 to 40. So which one is the model class? The class with the highest frequency?
30 to 40.
30 to 40?
Yes.
30 to 40 has a frequency of what? 40.
35.
Madam is 10 to 20.
Huh?
No.
No.
It's which one?
It's 10 to 20.
It's
which
that
is
one,
75.
Right? So that is the first step. We first identify the model class. Okay. So now that we have identified, let's put in the parameters. Our lower limit is 10, right?
10. Yes.
Frequency of the model class, 75. Frequency before?
45.
Yes. And the frequency after? 60. The class width, just get any two lower limits or any two upper limits and find the difference.
10.
10. And now we can put in our formula and compute that. And we're going to find 16.667. So please go and verify this. Any questions on the mod? No questions on the mod? So there are no questions? Is it clear? On the mod, is it?
Yeah.
It's okay?
Yes.
Helma,
Yes.
it's okay?
Yes, please.
Okay. Okay, now we move to the median. What is the median? The definition of the median?
Median is the observational score at the mid of ordered scores.
Okay, yeah. So from that definition, let's remember that we have to order the observations first before we identify the observation that divides the data set. Okay, so to find the median of the data set, again, with the first one, the other example, where do you think the median falls? In example 1? I mean, not this one, but the one that we had earlier. This one. 10 to 15, 15 to 20, 20 to 25, 25 to 30. Where do you think the median falls?
It's difficult to just predict, but unless this is being grouped data, we need to use a formula.
Okay, so being using since this is grouped data, indeed we need to use the formula. But what we notice there is that our data set is already ordered. Like the groups, I mean the classes, we start from the lowest to the highest. Therefore, this serves as some ordering. Then we just have to know where the median falls. So we first identify the class containing the median, and we call that class the median class. So the next thing that you do after to identify that, you have to create a row for cumulative frequency. The cumulative frequency. Okay, like in this our example 2, we have the cumulative frequency for each class up to 220, Okay, so now what you do is to say you get your 220 divided by 2. So you have your 220 divided by 2, you have a 110. And then you ask, where is 110 going to? Like 110 is the position. In which class is this position going to fall? In. Okay. So there, in which class can the 110 position fall? In which class? I'm waiting for the answers. In which class can the 110 position fall?
No class. We don't have 110.
Okay, let me just a moment, please.
Madam, you've muted your mic.
Okay, so the class is from the class where the 110th position falls is between 10 to 20. So you first identify the median class by dividing your total number, I mean the sum of the frequencies by 2, because you want the position which divides the data set in halves. That's why we're dividing by 2. So n divided by 2, 220 divided by 2, and you find what? 110.
110.
Then you say, where is 110 going to fall if I'm going to arrange this? Because they already arranged from the smallest to biggest. Your 110, and you check your cumulative frequency, your 110 falls in that where you find 120. Because in this class, there are just 45 observations. Here, they are up to 120 observations. So the 110th position will fall in that class. So that class becomes your median class. Now, when it's your median class, you now use the formula for the median. after identifying the median class. The median formula, the formula for the median just says you get the lower limit, then you add n divided by 2, which is your n is the total number of the frequencies, minus the cumulative frequency before the model class, divided by the frequency of the, the median class. And you multiply by the widget. Okay, so that is how you obtain your median, and from the example you'll be able to follow. Okay, so we'll quickly move to the variance for grouped data. It just says summation of fi times xi squared. Remember, the fi's are the frequencies, the xi's are the midpoint. Then you see this term there, sum of fi times xi. This is the term that we usually use when finding the mean. So as long as you already found the mean, you have this term. You just square it, and you divide by n. N in this case is the total number of the frequencies. And here n minus 1 is the total number of the frequency minus 1. So let me show you from an example how we compute that. Okay, so the standard deviation, we get back to our table. So what I did was to create a column xi squared, because I need this fi times xi squared. So I got the midpoints and I squared them. Then you get each midpoint multiplied by the frequency, and you get those fi times xi squared. Get the sum. After you get the sum, you now insert it in the formula. Now our formula says this sum of the fi times xi minus sum of the fi times xi, and then the sum this time is the one that you square. So this term is the one that we are just seeing from the column, the table. Then this 4,250 is the one that was computed when we were finding the mean. Now you just divide it by the frequency. Now we just divide by the frequency and divide it further on by frequency minus 1, the total number of the frequency minus 1. You compute that on a calculator and you find the standard deviation, the variance. So that is S squared, it is the variance. To find the standard deviation, we just square root the variance. Okay, so something that we can, that I thought I should add on was the coefficients of variance or variation, which is just the standard deviation divided by the mean times 100%. Then you insert that in your formula and you're able to find the coefficient of variation. So this is where we will end today on grouped data. So tomorrow we are going to begin probability. Any questions? Any questions? Or you still want to go through now, do the computations? Okay. So for now, let's go through the computations and let's also answer assignment 1, because it had, I think question 2 had most of this stuff. So familiarize yourself with computations on grouped data. So going through this example and going through assignment 1 as well will really help. If you have questions, you can still get back to me.
I wanted to find out, do we have a video recorded over for this lesson we just learned?
Yes, so the video will be ready tomorrow. The audio, it will just be an audio with us who are online using the videos will be just us who are online.
Okay.
Okay, madam, when calculating the variance, so when you look at the formula, summation of F1 x1 x1 squared. Is it x1 squared? I'm saying
it's xi squared, fi. That means for the
okay.
first class, the I ranges from the first class, second class, up to fifth class.
Okay, minus open bracket summation of fi closed squared.
Yes.
So
the first one you square the xi first, then the other one you have it as a sum, and then you square everything.
Okay. Now why didn't we use the mean which we calculated that side, because we had 19 point something? Why couldn't we use that mean?
Which mean?
Yeah, the 19 point something which we calculated.
Okay, so there's another formula for standard deviation or variance that makes utilize the mean. So you can just check that one out. But I prefer using this one.
Okay.
So you can check it out, but just make sure you check formula for grouped data. Don't use the formula for ungrouped data to find variance in grouped data. No. There are alternative formulas which you can use, maybe which you find simpler, but make sure they are for grouped data. If you use those, you will still arrive at the same answer.
Madam.
Okay.
Madam.
Yes, Geoffrey. Is it Augustine?
The same notes.
Which notes?
It's me, Joe.
For this present. Okay, so the notes are there on the portal. The notes are there on the portal. Even the notes are there. There are those written unit 1, unit 2. You can still find this. Even the lecture 1. This should be lecture 2, I think. You still find this. Okay. Yeah. All right. Okay, you guys, it's getting late. I'll see you tomorrow. Thank you so much for your patience.
Thank you.